Hi guys, my name is Terry from Teliti. I've been teaching mathematics and additional mathematics for more than 25 years. And differentiation is one of the most important chapters in IGCSE additional mathematics. So this video will go through IGCSE additional mathematics topical practice differentiation paper 1. And since this paper 1, we focus on solving the question without using a calculator. I'll show you how to differentiate accurately, use the gradient correctly, and avoid common mistake in question involving tangent, normal, stationary points, rate of change, and so on. So let's begin. So let's begin with differentiation paper 1. This is differentiation part 1. So we have to do dy dx and d2y dx squared. So let's begin. Square root means power half. So can we differentiate directly? So dy dx, bring the power half down, copy x, reduce the power by 1. This one, the 2 bring out, cancel with 2, left with 1, 1x, not just x. So you can stop here and differentiate one more time. Because you are finding d2y dx squared as well. Bring the power down. 1 over 2 times negative 1 over 2 is negative 1 over 4. X, reduce the power by 1, negative 3 over 2. Differentiate 1x, you get 1. Okay, actually you can stop here, guys. But I think if you check my answer, I did like simplify it. But if you don't, it's okay. It's okay to leave like this. Or if you want, you can leave it like this. Okay, so these are two versions. Okay, it's not a must to leave it in radical form or root form. Yeah, you can leave it as power negative, it's still okay. Now, next, find the small change in y in terms of x. Small change in y in terms of k. That means you're finding delta y when x reduces from 4 to 4 minus k. So let's find out your delta x. Your delta x is negative k. Right? So when you go from 4 to 4 minus k, what is the reduction? Reduction is negative k. Remember, you need to differentiate and sub x with the initial value. Initial value is 4. So initial value is 4. Let's put 4 inside here. 1 over 2. This one put inside here. Square root. You can put square root. I don't put power half. You can put square root. Minus 4 here. This is 1 over 4. Square root 4 is 2. 2 times 2 is 4. Minus 4, negative 15 over 4. So now to help you to visualize this, this graph, I don't know, probably looks like this. Initially, your x is 4. Now it reduces from 4 to 4 minus k. The reduction is your delta x. Your delta x is negative k. I'm finding small change in terms of y. Small change of y in terms of k. I'm finding my delta y. If your delta x is small, we say that delta y over delta x, which is negative k, equals dy dx negative 15 over 4. So what's your delta y? Multiply over 15 over 4k. That's all. Right? So this is true when your delta x is small. But always remember you got to sub in the initial value of x. In this case, initial value of x is 4. Yeah, this one is UV. So let's begin. Dy dx. Remember the formula looks like this. This is your U. This is your V. Okay, let me move this up a little bit. When you differentiate, it's V U prime minus U V prime over V squared. My V is x plus 2. U prime, bring the power down. Copy the bracket. Reduce the power by 1. Differentiate inside. Copy your u 6x minus 1 power half. Differentiate your v. Bring the power down. Copy the bracket. Reduce the power by 1. Differentiate inside still 1. You want you can write. Don't write, never mind. Divide by v squared, which is x plus 2 square bracket square. So let's simplify. I can cancel 2 and 6 left with 3. So we put them together. This one, you need to factorize. But okay, before I factorize, maybe I do slowly one by one. It's easier to see. I write 3 with the x plus 2 square, 6x minus 1 power negative half. There's another 2 with the x plus 2 I put in front. The 6x minus 1 power half I put at the back. Divide by x plus 2 power 4. Now here we have two common factors. The first common factor is x plus 2. So I will take out x plus 2 only. Okay. All right. Let me just write this first. The second common factor is 6x minus 1. When you have power negative half and power half, we take out the smaller one being negative half. So you're left with the 3. But the x plus 2 square, when you divide by x plus 2, you still have one more x plus 2. But for the second one, the x plus 2 is completely taken out. You still have 6x minus 1 power 1. Okay, now if you're unsure about this, maybe I just show you this way. I just use x and y. If I give you x squared y negative half, you minus x y power half. If you take out x, this will be x and y negative half. This will be y power half. If you take out y, take out smaller one, power negative half, right? This is x. What happened to this? Y power half divided by y negative half. It's actually y power half plus half, which gives us y power 1. So that's how you get x minus 1. Yeah? So let me simplify your denominator with x plus 2 power 4. You can cancel the power 1 with power 4, left with power 3. And the power negative half here, I can bring it down. Expand the bracket 3x plus 6 minus 12x plus 2 divide. So the first equation, 6 down here, 6x minus 1 with the bracket x plus 2 power 3. Simplify further, 8 minus 9x over square root 6x minus 1 followed by x plus 2 power 3. Because the question says write in the form of ax plus b, maybe I write minus 9x plus 8. Follow the sequence. Okay. We sub in 2 and 9. Your y is 9 when your x is 2. So we can form the first equation. 4a plus 2b equals to 9 minus 1 is 8. You divide by 2, 2a plus b is 4. Equation 1. Okay, then we differentiate dy dx. This is 2ax plus b. We have maximum point. At the maximum point, what's your gradient? The gradient is 0. So when x is 2, your dy dx is 0. Sub 0 inside. I think we can make b as a subject. Equation number 2. Let us sub equation 2 inside equation 1. Your a, leave it. Your b is negative 4a equals to 4. Minus 2a is 4. A is negative 2. Okay, once you got your a, sub inside equation number 2. Find your b. Negative 4 times negative 2, 8. Okay, question number 4, guys. Given point A and B lies on this curve, find the gradient of tangent at point A. So first we differentiate, right? Remember dy dx gives us the gradient function. So you differentiate 2x, you get 2. This is positive 3 times 2 is 6. Copy x, increase the power by 1. Then you substitute x with half. There's a half power 3. Now, I know, a bit hard for you to not use a calculator. 1 over 2 power 3 is going to be 1 over 8. You flip up, it's going to be 48, right? 6 times 8, 48. Your answer is 50. So the gradient of tangent is just 50. Okay? Hopefully you can do it without a calculator. Can you? All right, now next, find the when the x coordinate point B increases by p, the y coordinate decreases by 4p. So what do you understand by this? Your delta x is now p. Your delta y is negative 4p. Yes. All right. So find the coordinate point B. Remember, delta y over delta x is approximately dy dx. Yeah, when delta x is small. So your delta y is negative 4p. Your delta x is p. Your dy dx, I don't know. I don't know my dy dx value. I mean, I don't know the exact value, right? So we substitute dy dx with this. So I can find my x coordinate. We're finding x coordinate, right? So this one you can cancel as negative 4 equals to 2 plus 6 over x cubed. Bring over 6 over x cubed is negative 6, right? X cubed is negative 1. Cube root of negative 1. X is just negative 1. So once you got your x value, you take this. Okay, actually, do you need to find the y value? Guys, do you need to find the y value? No, we just need to find, okay, sorry. You do, yeah, find the coordinates. So you find your y value, your y is 2 times -1, 3, -1 square. This is -2, -3, answer -5. So we say coordinate point B is -1, -5. Is that correct? So a curve has this equation y equals to k x power half. I change to power half. Find in terms of k equation normal to the curve at point x equals to 4. So let us differentiate dy dx, bring the power down, copy k, copy x, reduce the power by 1. Now you need to sub x with 4. So as I put 4 inside, this is actually, let me write this as k over 2 square root x. Let us put 4 inside, k over 2 square root 4. Square root 4 is 2, so 2 times 2, let's write this as 4. So what does this represent? This represents the gradient of tangent. K over 2 is your tangent. Okay, remember, tangent and normal, the relationship is this. Tangent times normal is -1. My normal is -4 over k. Because you find equation normal. But the thing is, before you find equation normal, you need to find your y coordinate. So when your x is 4, what is your y? Your y is k square root 4, which is 2k. Right? So I know my x, I know my y. I can form the equation straight line by using what? Y minus y1, mx minus x1. So my y1 is 2k. My gradient of normal, -4 over k. My x1 is just 4. So you multiply inside. You can multiply over or multiply inside, up to you. As in, you can just times in. It's kind of easy. Just times inside. -4 over kx plus 16 over k plus 2k. There you go. That is your answer for part A. Okay, now next I want to find my value of k. Given a normal intersect the x-axis at 0.60. So if it does intersect the 0.60, right, we can sub in the coordinate 60. That means your y is 0 when my x is 6. Just sub inside. Okay, our job is to find k. So this is -24 plus 16 minus 8, right? -8 k 2 over k, 2k, bring over 8 over k is 2k, bring the k up, k times k is k squared, 8 divided by 2 is 4, square root of k is 2. Now, do you need to put plus minus? No. Why? Because k is a positive constant. So we just take the positive value, k is just 2. So a cylindrical water tank has radius of 2 meter, height of 5 meter. So guys, can I draw like this? This is your water tank. The radius is 2 meter. The height is 5 meter. Initially, the water tank is completely filled. Water is then released from the bottom of the tank, yeah, such that the height of the water level reduces as this. Okay, height of the water level reduced means what? Your dH dt is -0.5. Okay, so find in terms of pi, the rate of reduction of volume of water in a tank. Rate of reduction. The rate of reduction means we're talking about dV dt. You're finding dV dt. Guys, you can write this down first. dV dt is dV, put a dt, put a dH, put a dH. This dH dt you can sub inside. dV dH you can find. So that's why you have to go to the formula for volume of cylinder. Guys, volume of cylinder is given here, pi r square h. Right? So you put pi r squared. But the thing is, I want you to know the radius is constant, but the height is not constant. Yeah, water initially, yes, is full, but then the height will continue to drop as you release water from the bottom of the tank. So you should use your radius as 2 square h. So this part here is quite confusing to some people, because some people, they may put pi r square h and wonder how to differentiate. You should differentiate with respect to h, not respect to r. That's why I wrote this down first, so that you can see that we need to find dV dH, not dV dr. Your r is a constant, yeah? The radius of the water tank is the same, remains the same. So we differentiate dV dH, this is 4 pi. Take this 4 pi sub inside, yeah? So let's just write dV dt is
4 pi times negative 0.5 negative 2 pi meter cube per minute. You can put minute negative 1. Okay, so that is part A. Then volume water left in the tank after 8 minutes. Okay, this one is per minute, right? Initially, the water tank is full. What is the volume? In the initial volume? Initial volume is what? Pi r square h. So 2 square is 4, 4 times 5 is 20, 25. Correct? This is initial. You can call it VI, V initial. Yeah, up to you. V naught. Okay. So after 8 minutes, what is the volume after that? I call it V2. Every minute you drop by negative 2 pi. So we take 20 minus 2 pi times 8 minutes. Answer is 4 pi. Yeah, 4 pi what? Meter cube. So this one is a bit interesting because it actually reduces at the constant rate. That's why we can take dv dt minus 2 pi multiplied by 8. Because it reduces every minute, it reduces constant rate. It's not that the rate is accelerated or or reduces or things like that, right? It is constantly reducing at this rate because your dv dh or your dv dh is a constant, your dv dt is a constant. So we can use this. Okay, so let's look at the next one. A curve has this equation y equals px cubed minus 12x, where p is a positive constant, has two turning points. Find in terms of p the x coordinate of the turning point. So let us differentiate dy dx. So bring the power down 3px squared minus 12. So what is the first turning point? Guys, the turning point happens when dy dx is 0. So we let your dy dx be 0. We bring this over. This is 12. Divide 4 over p, right? 12 divided by 3 is 4. X is square root of this. Now, there are two turning points, right? The first one is positive 2p. Or can I just write plus minus? Square root 4 is 2. Square root p, I'll just leave it like this. Yeah, root p. Do you need to find the y coordinate? No need, no need. The x coordinate only. Now, to determine the nature, we do second order differentiation, d2y dx squared. Differentiate this. This will be 6px. Then you sub in the two values. The first one is negative 2 over square root p. Your d2y dx squared is 6p times negative 2 over square root p. Cancel them. Negative 12 square root p. Now, my question is this positive or negative? Guys, tell me, is this positive or negative? This value is definitely negative. You square any number, is always going to be positive. Yeah, and the plus p is a positive constant. P cannot be a negative constant because, for example, you put negative 4, what will happen? You get math, right? P itself is a positive constant. So this is positive. You square root it, is positive. You times negative 12. This is less than 0. Therefore, what type of turning point is this? It's a maximum point. Now, next we sub x with 2 over square root p. Your d2y dx squared is 6p times 2 over square root p. That gives us 12 square root p. This is more than 0. It is a minimum point. One is a maximum, one is a minimum. This diagram shows the graph of y equals to x squared minus 3x, which intercept the x-axis of origin and point A. So line AD is a tangent to the curve point A. Find the gradient. Okay, at point A, what is the gradient? So let us, first of all, we find point A. At the x-axis, y is 0. So your x squared minus 3x is 0. You take out x minus 3 equals 0. X is 0 or 3. So can I take 0? Cannot. Why cannot? 0 is the origin. Take the second one. Therefore, my A is 3, 0. You need to find coordinate point A. So then we differentiate dy dx. This is 2x minus 3. Substitute x with 3. You get 6. 6 minus 3. Can I write 3, 3? 3, yeah? So that means the gradient of tangent for line AD is just 3. Yeah? We want to find gradient tangent of straight line AD. So I'm done. Part A. Part B, given that BCD is a tangent to the curve C and is perpendicular to straight line AD, find coordinate point C. Okay, C is perpendicular to AD. So we need to find gradient of BCD now. Yeah, or you can call it BD. So gradient of BD times gradient of AD, which is 3, the result is -1. Your BD is -1/3. So once you got this BD, right, guys, we can do what? Dy dx, let it be -1/3. Because remember, dy dx is your gradient of tangent. The tangent at A and the tangent at C is different, right? Tangent at A is 3. Tangent at C, sorry, is -1/3. So you take a dy dx here, the function, gradient function here, you let it be -1/3, bring it over, this should be 8/3, right? 3 times 3, 9, 9 minus 1, 8/3. You divide by 2, sorry, very ugly. I divide by 2, my x is now 4/3. So once you got your x value, right, when you find your y value, so your x inside your equation, which is x squared minus 3x. This is 16/9 minus 4. 16 minus 36, -20/9. I hope you can do mentally, yeah? Yeah. So therefore, your coordinate of point C is 4/3, 20/3. Give it a negative. Thank you. Guys, this line is parallel to tangent. Find the value of constant k. So for me, I do a sketch. Let's say this is a curve. This line is a tangent. When they say the line is parallel to tangent, that means it looks like this, right? This line is kx plus 2y minus 8 equals 0. We rearrange it. We rearrange your y equals mx plus c to find the gradient. My y is -1 k/2x plus 4. My gradient of tangent is -k/2 because the tangent is parallel to this line. But we need to differentiate your y to find the gradient of tangent. Okay, guys, remember how to differentiate this? I use a composite function, a reciprocal composite function, negative in front. 5 times 1 is 5. Copy the bracket, increase the power by 1, 2, differentiate inside -1. Then I immediately substitute x with 3. Put 3 inside 5. 4 minus 3 squared, this is 5. And what's your dy dx, guys? Your dy dx is your tangent, which is -k/2. The result is 5. K is -10. Okay, so how do you make the equation a normal? I got my k value. So we already know your tangent. To find the normal, what do? We know tangent is k. Actually, tangent is 5, right? Normal times tangent must be -1. So my gradient of normal is -1/5. So we can use y minus y1. Okay, the problem is, do you know what's your y value? I don't have my y value. I know my x is 3. Find my y value, 5/4 minus 3. This is 5. So you do y minus y1, gradient m, x minus 3. Yeah? So just multiply. You can leave it in any form. You can write in general form. You can write in gradient form. Doesn't matter. So let me rewrite. X plus 5y equals 28. Right? Given diagram shows water container in the shape of a prism with a cross section of equilateral triangle PQR. The length of PQ is x and the depth of water is h. The length of container is 10 square root 3 cm. Show that the volume of water in the container is given by this. Okay, so what do you do first, guys? We differentiate the okay, before we differentiate, sorry, we know volume of water, right? It takes the shape of the container. The container has a cross-section area of a trapezium, we call it an equilateral triangle. Guys, we know area is x half times base times height. Your base is x, your height is h. Now, the problem is your answer is in terms of h, no x, right? So if you take the volume, right, you can say the volume is cross-section area times the length. What's the length? 10 sec 3. That gives us 5 sec 3 xh. So here's the problem, guys. Your answer has x and h when I need it to be only in terms of h. So we define what is the relationship between x and h. Guys, we know equilateral. Equilateral means what? Hey, this angle is what? 60, yeah? Okay, let me highlight for you. This angle is 60. So we can draw a that cross-section area is 60. The height h is over here. This is going to be x over 2. Why x over 2? X is the whole thing, half of it, x over 2. So we can use tangent 60 is h over x over 2. Tangent 60 is 3, h. Can we flip it up? We flip it up, this becomes 2h. Guys, this is what? 2h. 2 goes up over x. We need to make x as a subject. Your x is 2h over square root 3. Equation number 2. So why do I leave it like this? Why do I make x a subject? Because you want your answer to be in terms of h. You don't want x, right? So you sub equation 2 inside equation 1. Your volume is 5 square root 3. X is 2h over square root 3 times h. Simplify further, then h squared. There you go, you got your volume V in terms of h. All right, now next, the container is filled with water such that x increases at this rate of 0.8. Find in terms of set3 the rate of change of h. Okay, so first of all, x increases at this rate. That means your dx dt is 0.8, right? You are finding dh dt. You're finding dh dt. So guys, dh dt equals dh. What do you write here? d what? Anyone? dx, huh? dh dx, right? So the thing is, we need to find dh dx. We already have dx dt. Dx dt is this 0.8. dh dx, you go back to this. Hey, go back to this formula here. This one. You differentiate dx dh, you get a constant 2 over sub 3. But please take note that this is dx dh, this is dh dx, this is dx dh, the other way around. So you got to invert it. Therefore, my dh dt is sub 3 over 2 times dx dt 0.8. 0.8 is 4 over 5 sub 3 times 2 over 5. Yeah, this h is the unit. If you want to write, don't need to write that, but if you want to write, is cm per second. Okay, lastly, rate of change of volume when the height is 4. Rate of change of volume means you're finding dv dt. You're finding dv dt. dv dt is dv with a dt, put the dh and a dh. My dv dh we can find very simple. Go back to this formula here and differentiate, right? Go back to your v in terms of h, differentiate, you get 20h, and you're finding the rate when height is 4. Height is 4, so let's put 4 inside, you get 80. Your dv dt is therefore 80 times your dh dt, which we have it here, 2 sub 3 over 5. Now 80 divided by 5 is 16, right? Or you cancel like this, 16. 16 times 2 is 32. Answer 32 sub 3. Your answer will be in terms of sub 3. Yeah? This will be cm, volume is cm cubed per second. Okay. Diagram shows a metal plate which is obtained by removing two semicircle A and D and B and C of radii xcm from rectangle ABCD with length of AB is y. The perimeter of the metal plate is 18 pi. So show that area metal plate is given by this. Okay, so first of all, I hope you know, so circumference is 2 pi r. This is half of a circumference. This is half of a circumference. If you combine together, it's still 2 pi r, right? The radius is x, so your diameter is 2x. Okay, we can use, first I form an equation involving perimeter, or you can start with area first, up to you. I do perimeter first. Our perimeter is 18 pi, so it's two semicircle combined together, so it's a one circle. The length will be 2 pi r, your r is x, plus 2y here. This 2y I need to add together, y plus y, so that is 2y. The result is 18 pi. So notice the answer is given in terms of x. There is no y. So you need to make y as a subject. We start by dividing by 2. Pi x plus y is 9 pi. Make y as a subject. Yeah, equation 1. Second equation, I'll take a rectangle minus the 2 semicircle add together, which basically you're subtracting a circle, one circle, pi r squared. So your area is 2y times x. Maybe I write x, 2x times y is better. Follow the order. 2x times y. 2x is the width, y is the length. You minus pi x squared. Now notice that your answer is in terms of x, there is no y. So we sub 1 in 2. Your area is 2x, 9 pi minus pi x squared. So this is 18 pi x minus, this will give us 2 pi x squared minus pi x squared. So your area will be 18 pi x minus 3 pi x squared. Okay. Next, determine whether A has a minimum or maximum value. Find the minimum or maximum value A. So we've done something like this many times, right? Just differentiate dA dx. That'll be 18 pi minus 6 pi x. Okay. So let your dA dx be 0. Maximum happens when this is 0. Bring it over. 6 pi x is 18 pi. 18 divided by 6, answer x is 3. Okay, so we need to determine whether it has minimum, maximum. So this is where you have to do second order differentiation. Take this, differentiate one more time, you get negative 6 pi. Okay, so this is less than 0, so we know it has a maximum value. A has a maximum value. To find the maximum value, right, we need to take our x value here, sub inside your A. Right, your A is therefore 18 pi times 3 minus 3 pi times 3 squared. 18 times 3 is 54. 3 squared is 9. 9 times 3 is 27. 54 minus 27. Answer is 27 pi. Okay.
Now, lastly, when the metal plate is heated, the value of x increases from 2 to 2.1. So what is this? This is your delta x. This part here, your delta x, when you go from 2 to 2.1, the increment is 0.1. So now we're finding approximate change of the area. That means you're finding delta A. Remember, delta A over delta x is approximately dA dx. We use this when your delta x is small, right? And the delta x is 0.1, which is small. We just have to find our dA dx first, guys. When your x is 2, just now x is 1, it's 3, and now x is 2. So you sub inside your dA dx. dA dx will be 18 pi minus 6 pi times 2. 6 times 2 is 12. 18 minus 12 is 6 pi. So take your delta A, divide by delta x 0.1. The result is 6 pi. Multiply over, you get 0.6 pi. Okay, so that will be in cm square. Again, unit, don't write, never mind. So when your x increased by 0.1, your area of the metal plate increased by 0.6. Diagram shows sector of circle with radius of r. Angle subtended at the center is theta. So the sector is formed using a piece of wire with a length of 24. Right, so that means that this is r, this is r. This one, the length is, we can use s equals r theta, right? Now, the area, show that area is given by that. Okay, before you do area, right, you notice your area is in terms of r. There is no theta involved. They say the length of the wire is 24 pi. So can we add together r plus r, or 2r plus r theta equals 24. You need to make theta as a subject. Why? Why do I make theta as a subject? Because your final answer A has no theta. It's in terms of r. So theta is 24 minus 2r over r. For this equation 1. Your second equation, you know, area of circle, right? This is like circular measure, half r squared theta. Equation 2. We sub equation 1 inside equation 2. The moment you sub inside, don't write your theta. Write 24 minus 2r over r. Cancel r squared and r. Yeah, I cancel r squared and r. Just multiply inside. 24 divided by
2 or times half is 12. So this is 12r. The half cancel with 2, left with 1r, r times r squared. Yeah, answer is given, so it's very easy. We just double check, yeah, with the answer given here. Now, next, the radius of the sector increases at a constant rate of 0.2. So, meaning your dr dt is 0.2. Okay, find the rate of change of the area when theta is 2.8. So, we are finding what? We are finding dA dt, right? When we can break this up, I put the dr. I put the dr. This dr I can sub inside. dA dr I can find. I can find from here. So differentiate dA dr, 12 minus 2r, sub, wait, hang on first. Before I do that, sorry, you need to find when theta is 2.8. We don't know theta, we don't know r yet, right? Correct? We don't know r yet. So we need to take 2.8 and put inside here, find your r. Okay, it's not really helpful if I put here. Yeah, maybe might as well put inside here. I can't call this equation 0, right? I call it equation 3, yeah? You know what I'm saying? I'm finding rate of change of area, right? Okay, so let me do sub theta equals to 2.8. So your 2r plus r times 2.8 equals 24. So this is 4.8r equals 24. What's your r? Okay, I'm sorry. A lot of people cannot do this mentally, right? Can you switch the decimal point? Switch one decimal point, 48. Switch one decimal point, what do you get? 240. Yeah, do you know 48 divided by 2 is 24? Or is it an easier way to do this? Is there an easier way? You divide by 48, this should be 5, right? Is that? I know, right? It's a bit hard for you. Is it a bit hard for you to figure out? Is it better if I put 24 over 4.8? I divide by 24, I get 1. Divide by 24, I get 0.2. So 1 over 0.2 is 1 over 1 over 5. R is 5. Remember, I got to do this without using a calculator. If not, use the long way, long division. So you know your R. Okay, but you need to take your R, sub inside your dA dr. Your dA dr is therefore 12 minus 2 times 5. That gives us 2, right? 2 times 5 is 10, 12 minus 10 is 2. Then you take this, I know it's very long, 7 marks. Sub inside here, your dA dt is therefore 2 times 0.2, answer 0.4. This will be cm square per minute. Yeah? Now, next. Okay, once you got your R, right? You got your dA dt. Next, find the value of R if theta reduced at this rate. Okay, now you're given the rate of reduction of theta, d theta dt. D theta dt is negative 0.15. Okay, this is negative 0.15. Okay, you're finding the value of R. You are also given the rate of reduction of, you already know your dr dt, right? Guys, you know dr dt, right? 0.2. One is decreasing, one is increasing. So guys, if you know d theta dt, dr dt, what can we do with this? I can use the chain rule. Yeah, I think we can go back to d theta dt, d theta dr, this is dr, equals to negative 0.15. Okay, maybe I write down this formula. Write down your d theta dt multiply with dt dr. d theta dt is negative 0.15. dt dr is 1 over 0.2. So again, we switch the decimal point. So you get negative 1.5 divided by 2, right? Negative 1.5 divided by 2. What is it? Negative 0.75. d theta dt, d theta dr is 0.75. 0.75, you can think of it as 3 or 4. Now you take this one. Okay, now I start to regret. Maybe I shouldn't write this. It's very long, very hard to differentiate, right? Maybe I should take my theta here and write this as 24 over r minus 2. Easier to differentiate. d theta dr is negative 24 over r squared. Take this 0.75, sub inside here, negative 24 over r squared. Our job is to find r, right? Okay, 0.75 is 304. Use 304. A bit ugly. 24, bring up, bring down. 24, you divide by 3, it's 8. 8 times 4, 32. 32, right? The problem is, if you square root, you don't get a nice answer. 32 is, you think 16 times 2. If you square root it, you get 4 sub 2. That's your r. Yeah?
If this video helped you, you can get my advanced book from Shopee or Lazada or by searching Teliti. For full step-by-step learning, check out my e-course or join my classes at Tuition Teliti. Remember to like, subscribe, and share. See you in the next video.